This is my programming assignment 4. So for programming assignment 4, there are three requirements: load balancing, ownership strings, as well as the past X number of records for the quality of service. So regarding the first requirement, my strategy is pretty simple. So we gonna pre-populate the assignment between topics as well as brokers. So that pre-population will be handled by the discovery service. So upon discovery service bootstrapping, it will create a map. So let me just quickly show you here. So it'll create a map similar like this. Well, actually, it's a list. So there are total of 3 lists, as we discuss on the Slack channel. So there will be 3 groups in the list, and that was to construct all the 12 brokers. So each item has a topic, has a list of topics, as well as the brokers. And this is group ID is also the broker group ID. So you can see I have 3 groups. The first group has this number of topics. Second groups have this number of topics, and third group has this number of topics, right? And of course, each group has their own dedicated brokers. So this concept has been confirmed with the professor, so we can use that. So basically, once discovery service start up, it will pre-populate that topics. Will populate that groups, and every time there's a new broker, was a register, it will make sure it will return. It will guarantee to let the broker to subscribe the right publisher, which belongs to the same group. So I believe the code should be here. So where's the assignment? Okay, so type response and the reply. Okay, register response. That's in the discovery. Okay, here. So as you can see, there is a check. Okay, here. Basically, I'm checking. Okay, is this topic belongs to the same group ID as a broker? If they are, it will assign the right topic to that broker, and that broker will just be tied into that that topics. So that's basically the strategy for requirement 1. So for requirement 2, pretty straightforward. In order to steering between the topics and the publisher, what we just same as how broker was elected, like primary backup, we just create so every time publisher a bootstrap, it will just create a entry on the zookeeper, and whoever creates that a zookeeper value first will be the the owner of that topic. So the code should be here. Yeah, so here. Yeah, it will list all the topics the publisher published, and then create an entry on the zookeeper. Yeah, also pretty straightforward on the requirement 2. So for the requirement 3, same concept. We just introduce another Z node, a zookeeper node, to basically store, okay, what's a past X number of records I have, and also when when the broker subscribes, it will receive the well actually when the broker subscribe, it will receive the last X number of records and then publish to the subscriber. Okay, then let's just jump into the fun part, which is a demo. Okay. So here's my virtual machine. Just queue the zookeeper, making sure no background job is running. And then I'm gonna launch a 20 nodes mini net. So before I run the script, I just want to show you, what I'm gonna demo here. So the first line is to start up a zookeeper. Second line is to start up a discovery service. Third line, fourth line are starting basically two publisher. Both of them will publish all the night topics. Okay, and then I'm gonna start another two brokers. They will belong to the same group, and then I'm gonna start a subscriber that's subscribing a topic from the first group, which is location, right? So let me just launch them one by one. Then we launch discovery service. Let's confirm discovery service is running. Okay. And then publisher number one. Let's confirm publisher is running. Okay. Publisher number two. Broker number one. Broker number two. Okay. So confirm publish two is running. Okay. Confirm broker one. Confirm broker two. Okay. So at this moment, broker one should be the primary, the primary, broker service. And then, yeah, of course, the subscriber. Okay. Confirm. What's going on? Sub one. Something wrong on the broker one. Interesting. Oh, so there's no location. Okay, let me let me just change there's I think okay, so probably it's a random order when during the pre-population, because last time that was a location. So this moment, let me just kill the subscriber. H7 Q 441 018. Okay. So let me just okay, let's do weather here. Okay. Here we go. Okay, it's subscribing weather. So at this moment, let me just tell both broker 1 and broker 2. So broker 2 is actually the backup broker. So you can see this indicates for requirement 2 actually. The strings right now the strings is pub 1. So both of them is actually subscribing to publisher number 1. So let me just tell the pub 1 log and the what folder am I in? H1-vandy sys. And then pub 2. Okay. And of course, subscriber 1. Okay. So, and now what I'm going to do is I will queue the publish number 1. Okay. 3 PS publish number 1. So once I queue it, the broker cluster will switch, the subscribing from pub 1 to pub 2. Okay. So let's see here. Okay, let's see. Okay, so I believe this is pub 1, so it's not getting any data now. Okay, see the line here, topic strings, pub is pub 2, so it's subscribing from pub 2. So we can confirm pub 1 is no data, right? So there's no data on pub 1, but pub 2 is still publishing data. And meanwhile, I think there's so there's a kind of a fault tolerance kick in, so that the subscriber 1 is still subscribing from the broker 1, and broker 1 will switch from publisher 1 to publisher 2. So I'm still able to subscribe the weather. And then what I'm gonna do is I'm gonna queue the min broker, okay, which is on H5 broker 1, basically broker 1. H5 the broker. So once I queue it, the first broker, so this is the first broker, the second broker will kick in, and the subscriber will subscribe from the second broker, the broker 2. Okay, so I queue the min broker, so broker down, and okay. So this is a subscriber. Subscriber is changing from broker 1 to broker 2. Okay. What else? Yeah, and also for the QoS. Let's see if I have this here. That was actually at the very beginning of the startup. So because when we run broker, we actually give parameter for this is going to be the last 5 records. So those are the last 5 records for the history QoS. Yeah. So that's for requirement number 3, and also there's a graph that I pre-populated. Basically compare with a cluster where there's load balancing, and of course there's a cluster with load balancing. As you can probably see, definitely the one with load balancing has much better performance, because it just sharding all the traffic to different to different groups. Yeah, so I will check in this graph also in the GitHub. So yeah, so that's pretty much about it. Yeah, thank you for all the reviews.